So my voice should be will be audible right now, but it might be having a lot of noise. So do confirm it's audible and it's not the kind of having a lot of noise, because the mic is not working right now. So I am gonna go with the inbuilt mic, which will have a lot of noise, but it should be audible. Okay, noise. Let me add a filter as well. Let me add a noise suppression, noise gate. So it should be better now. Do confirm if the voice is better. It's clearly audible and there's not a lot of noise in the voice. Just do confirm that, then I can start on the session. Deva, I guess you should be able to hear me right now. I have changed the mic and it's working perfectly. So can I start the session? Okay, great. So let me open the whiteboard and then we will start on it. Okay, great. So this bootcamp, this computer vision and CN bootcamp, that's going to be 6 to 7 day long. Okay, so on the day one, like today, we will start with artificial neural network. We'll start with artificial neural networks. We'll see a basic of them, like what are ANNs, why do we need to use these, and what how they actually work. Then on the second day, we will let me just open the notepad, then it would be better. On the second day, we will continue with the ANN and see a bit of coding about ANN. On the third day, we'll see backpropagation, and then we will see with digital image processing and how the digital images are stored in the computer and why ANN is not that good while working with that. Don't worry about this. It's just the syllabus that I'm going through for the bootcamp. We will be going through these on the daily basis. And on the fifth day, we'll try to cover the convolutional network, and at the end day, on the last day, we will cover the project. So that will basically be the syllabus for this bootcamp, right? Okay, let me just adjust the camera a bit. Let me see if it's fine. Okay, so it should be better now. So it will be the syllabus for the bootcamp, and we will be following this one throughout the session. So let me start on with the today's topic, which is artificial neural networks. We will start with ANN, and let me see. Do let me know if the presentation is visible to all of you. And if you want to, if you want this presentation, this is there in the description of the video. You can just go to the video link. Let me get that. Just go to this video, and there in the video you will see the link over here. Just copy this link, paste it. Okay, so copy link address, paste that link, and in the link you will see the PDF over there, neural network.pdf. So it's a presentation that I'm going to use throughout the for the first session today. If you want to access this, you can access it from over here. And I guess I can right now start on with the session. Okay. So today's topic is neural network. So let's start with that. Let's talk about the history of them a bit. So neural networks were inspired in early 1940s by a researcher who tried to implement some idea of neural computer. Okay, so neural networks, they were inspired from human itself. Let's say we have a human body, we have a neural system, right? We have a neural system, and which consists of a lot of neurons Okay, in a human body, we have a neural system that if we touch something and if we feel it's hot, so that's through the neural system that we have in the body. So that consists of a lot of neurons, a single individual units. So the idea of neural network were inspired from that itself, from the human body. Okay, and like these are some, like we will go through this thing, the history and all, the usage later on. Let's just dive into the neural network itself. See, in our body we have a neural network, which consists of a lot of neurons like this. Okay, let's say it's a human body. Just mind the drawing. Let me see with the like if there is an issue with the network. The network is perfectly fine. It should work. There should not be any lag in the stream, but still I don't know why it's lagging. Okay, like anyway, I guess it's fine right now. So I'll just keep my video off just to save the bandwidth, and we will continue it like this. Okay. So let me know what the last topic, what was the last thing that you were able to get. I was talking about neural networks. Let me know what was the last thing that you were able to get. Showing poor connection over there. It's showing fine connection over there. Okay, just finish the first page. Okay, fine. I'll go through this page again. So what I was saying was, let's say it's a human body, and let's say you touch a kettle. It's hot, so your skin first acts as the input source. Your skin, as soon as you touch the kettle, your skin takes in the temperature as the input. It sees the temperature, and whatever is the temperature, it passes on to the neuron. It's the first neuron, let's say neuron 1. It takes that input through this root like structure called dendrites, I guess. It takes that input, and after taking that, it processes it somewhere. It gets the information and do some computation on that. It process it, and whatever is the result, it passes it on through the root like structure again. It passes on some information, let's say O1. Then the second neuron, this takes this O1 as input. It takes this O1 as input and then process it and passes its result as O2. And the information this information keeps on passing on until it reaches the brain. The information reaches the brain, and then your brain decide what you should do. If the kettle is too hot, your brain will decide to move your hand back, and you will quickly move your hand back. So that's how a human neural network works. So let me know if it's clear to everyone, the stream and all. Okay, great. So in the case of artificial neural network, we try to mimic the same. We try to mimic the same thing. Okay. So the property of the neural network that human body has is neurons are connected to and receive electrical signal from the neurons. So what happens is the information that they passes on, the information that it passes, it actually in the form of electrical signals. So it takes the information in form of electrical signal, and the information it passes on is again in the form of electrical signal, and it takes that, and this electrical signal keeps on passing until it reaches the brain and take the final action. And this thing neuron process input signals and can be activated. It means then each neuron takes the input and process it, and based on the result it passes on the information to the next neuron. Okay, now the question is how we can apply this idea of biological neuron to machine. So we mainly try to apply this thing of let's say we have neurons passing information from one neuron to another to predict some output. We try to do the same thing with the machines. Okay, so that thing basically is called artificial neural network because it's a copy of neural network and it's made artificially by humans. So it's called artificial neural network. Okay, so let's just dive into that. So it's a biological neuron. It's quite complicated, but artificial neuron that we made is generally represented by a circle. So it's quite easy to make, and we can represent it using a circle itself. Okay, so this represents biological neuron and it represents artificial neuron. And again, the neuron are connected to pass on information. So let's say it's a neuron 1. It will take some information input. It will process the input, and then whatever is the output, it will pass it on to the, let's say, O1. And the second neuron will take this O1, process it, and it will pass the output as O2. It will keep it, and this passing of information will keep on happening until it reaches the end. Okay, it's just a basic idea. We will see in detail how these things actually work. So I'm just giving a basic idea of how we actually try to implement the concept of biological neuron into artificial neuron. Okay, so let me know if this thing is clear to everyone. Ambuj, I told how we can get the presentation in the beginning of the video. You can just rewind the video and see it. Actually, the link to this PDF is there in the description of the video. If you can just go to the description and see the link over there, just get this link, and okay, let me just show it again once more. Paste the link, and you can see this neural network.pdf. So it's actually the PDF that I'm using right now. Okay, so if you want to revise it, you can get it from over there. Ria, don't worry about that. We will see how these neurons are actually connected. I'm just giving you a bit of idea right now. This way we try to mimic the thing. Okay, so good. If it's clear to everyone, we can actually move on. What we actually try to do with neural networks. So let's say we have a neuron. Let's say for right now, let's keep artificial neural network as a black box. Just keep it as a black box. By black box I mean a box in which you don't know what is happening. We don't know a thing about that. Just keep it that it takes some input, and based on this input it predicts some output. Okay, so one example we can use artificial neural network is to predict, given some information about a person. Let's say it was a Titanic ship and there were a lot of person in that. So we give some information about person 1, and we try to predict whether he has survived the Titanic ship or not, the Titanic incident or not. So this thing can be used by the ANN. ANN can be used to predict this thing. It's just one example. It can be used for a lot of things. It's a kind of small application for that. It takes the information of a person. It takes the information about a person. It takes a person data, this black box, which is actually ANN, and based on this information, it predicts whether the person survived in the incident. So that's like it's just a small, it's just a small application. The ANNs are quite powerful and it can be used for like a lot complex tasks than this one. So let's just dive in how we actually what is ANN. Like ANN is short form of artificial neural network. Artificial neural network. So I'm just referring ANN to term as artificial neural network. So again. Okay, so I've changed the network and hope it works very well. Like it doesn't break again. Yes, the recording for that session will be available to all of you. So if you want, you can see the recording at any time with any thing that you want. So recording is not an issue, just the stability of the network is an issue right now. And I'm trying it doesn't fall again. What is PTCL2? I don't know why the network speed was fine. Still, I changed the network and it's at least working. I'll see by like from tomorrow. I'll try like if this thing doesn't happen. So yeah, now let's see like how actually the neuron work. Let me do one thing. Let me pop this chat out. So I have popped out the chat or popped out the chat on the. We have popped out the chat on the right hand side of that, and let's see. Like, let me know. Okay, so it's intent provided in the Pakistan. Okay, actually I'm in India right now, so I can't use that. So, like, do let me know in the chat section if the network falls again. Now, coming to the how neural network actually work. Okay, so let's say it's a neuron. Let's just talk about a single neuron. So it takes some input. Now we know computer only understand numbers. It only understand numbers. It can't understand English or any other language. So it always. Let me see. Just give me a minute. So it cannot understand any other language. It cannot understand any language. So it will always try to keep the things in number. So all the information that we are passing, all the information that we are passing will pass as some numbers, and the output that we will get will be number itself. Yeah, actually it's binary number, so it's 0 or 1. But let's say I'm passing 15, so that can be converted as in binary form. So let's say I'm passing 5, so that can be written as 101 in binary. So we can keep it like simple numbers, like any number, but in the backend, like when we pass a number, it will get converted into binary itself, like 1 or 0 form. So it's fine. Like we can just keep it numbers for now. We don't need to convert the number into binary. The computer will convert that into binary automatically. Okay. So this neuron that you're seeing over there, let me clear that. So this neuron that you're seeing over there, it will accept only numbers. It will take some information. Let's say it's taking the first number as x1, it's taking second number as x2, and it's gonna predict its output, let's say O. Now let's say this neuron actually wants to predict the price of a house. It wants to predict the price of a house. And the input it's taking is, let's say the first input is the area of the house. And the second number is representing number of floors in the house. Okay. So the first input is represented as x1 and the second input is represented as x2. So it will take these two numbers and predict its output based on that. Let's say the output is h of x1 comma x2. Okay, I'm just writing it as the function in the function form, that it predicts some output based on this x1 and x2. So how it will actually calculate its output is, it will take three random numbers. It will start with three numbers, W1, W2 and W0. And it will calculate this value, W1 x1 plus W2 x2 plus W0. It will calculate this value, and whatever this value comes up, it will be the output of the neuron. It will be the output for this neuron. Now don't worry about that, like how we will get these values, how we will actually get the correct value for W1 and W2. Let me give you an example. Let's say the price of the house, okay, the area of the house, and let's say the number of floors, and then the price. The area is in, let's say, 100 meter square unit, and the number of floors are like rupees, and the price is in 10 multiple of $10,000. Okay, let's say the area was 5, number of floors were 1, and the price was 50. Like it's actually $50,000. Let's say for the second house, how it was for house number 1. Let's say for house number 2, the area was 10, the number of floor was 1, and the price was, let's say, 200. Okay, let's just keep it 52 and let's keep it as 202. And let's say for the third house, the area was 5, the number of floors were 2, and the price was 102. Now, from this data set, we can conclude, okay, for this data set, if we take W1, which is getting multiplied with with the area of the house, we can see, like from this data set, we can see when the area of house was 5 and when the area got doubled, the price almost get 4 times. Area get 2 times, the price gets almost 4 times. And when the area is same, but when the number of floor become twice, the number of floor increase, the price almost become 2 times. You might be saying that 52 times 2 is 104 and 52 times 4 is 208. Just forget about these two right now. Let's just keep it as 50, 200 and 100. If we take it as 50, 200 and 100, it's actually 4 times and 2 times. So we can say the area of the house, if the area gets doubled, the price gets 4 times. So area of the house gives double the impact than the number of floors in the house. Because when the number of floors in the house are getting doubled, the price is only getting doubled. But when the area is getting doubled, the price is getting 4 times. So area gives more the area, the larger will be the price compared to the number of floors. So we can set w1 as 2, w2 as 1, and w not as 0. Like, I'll show you this thing right now. Just don't worry about that. If I set it as 2 and set it as 1 and set it as 0, you will see initially when it was 5, okay, and it was actually 1. So it's actually 2 times the area of x1 and 1 times this number of floors. So if this thing gets doubled, this thing x2 gets double, the this value will increase by a factor of this much. Like, if this thing get double, this thing will get increased by double value itself. But if this thing get doubled, then this thing will increase much more. Like, the area of the house has more weightage.